let us get started with our statistics project. So let me open up my terminal and let's create a new mix project. So let me go inside my folder of functional programming with Elixir, and then let me go inside my folder of code, and right over here I want to create a new project. So I can say mix new stats, and let me open up the folder in a new window. So this is going to be our new statistics project. So let us see how we can implement our population and sample mean functionality. So the first thing is, inside the folder of lib, let me create a new folder and let me call that folder as central tendency. Now inside this folder, let us create another file. So let me create a file, and this is going to be for calculating our population and sample mean. Let me collapse my sidebar, and first let us define a module. So this is going to be stats.centralTendency.mean. So here first let us see how we can calculate our population mean. Now the formula for calculating the population mean is very simple. We simply have to take the sum and we have to divide that sum with our count. Now in terms of statistics, this sum is also called as sigma. So let us see how we can calculate our population mean first. So let's define a function called as population mean. This function accepts a list of our numbers, so we can call the argument as numbers, and let us see how we can define the body for this function. But before we can define the body, here we need to do a lot of validation. The first validation that we need to do is we need to check if this numbers is actually a list or not. So for this, we are going to use a guard. So let us go to the official documentation and let us try and see if we can find the right guard or not. So inside the module of kernel, we have a section for guards. So let us check if we can find the guard for list or not. So if I scroll a little bit down, here we have one guard, and this guard is right over here, is list. So let us see how we can use this guard in our function. So here what we can say that we want to have a guard saying that is list, and let us pass the variable of numbers. So basically what we want to do is we want to run this function only when this numbers is a list. Now we have validated that this numbers is a list. But what happens if this numbers is not a list, or in case the numbers is an empty list? So let's define one more function overload on the top. So here we can define that we want to define the same function population mean, and in case if we get a blank list, then at that time return back a blank list. Now we can either return back a blank list or we can also return some kind of an error. So for example, if you want to return some kind of an error, so we can return back a tuple and we can say that this is going to be an error, and we can also return back a message saying that invalid data type. So it's up to you. If you want, you can return back a blank list or you can return back an error tuple. So this is just for your reference. So now let us see how we can define the actual body for our population mean. So here we need to do two things. First, we need to find out the sum or the sigma, and then we have to divide by the count. But before we do all of these things, we need to do one more validation. So till now what we have validated is that this numbers is just a list. But we also need to validate that this is a list of numbers. So let us see how we can validate this one. So here let us create a pipeline. So here we can say that first I want you to take the numbers, and then I want you to pipe this numbers inside a function, and we can call that function as validate our number list. So we have not defined this function, but let's define it right over here. So let me just copy this one and let us define a function right over here. So validate our numbers list. This accepts our list of numbers, and let us see how we can define the body for this one. Now for this function, let us return back a tuple. The first condition would be either true or false. The second condition would be the numbers. So in case if this list is not a list of numbers, we will send back false. But in case this is a valid list of numbers, then we will send back a true right over here. So let us see how we can do this thing. Unfortunately, it's very simple. So here let us use the inbuilt module of enum, and I want to use the function of all. Now this all takes two arguments. The first is going to be our enum. So let us pass the enum of our numbers. And this also takes a function. So let us define a function right over here. Now what happens for each iteration, we are going to receive an element from our list of numbers, and we simply have to check if that element is a number or not. So here we can use an inbuilt function called as isNumber, and let us pass the element to this one. And that's it. We have defined a function to validate all our numbers as well. Let us also write the type specification for this function. So here we can say that the specs for validate number list. So this receives a list of our numbers, and this function returns a tuple. The first is going to be our boolean. The second element is our list of numbers. Let us go back to our function of population mean. So now we have all of the validation in place. Now this function returns back a tuple. So what we can do is we can simply take that tuple and we can pipe the output in yet another function. So let us call the new function as calculate population mean. So we have not yet defined this function, but let's define it right over here. So here we can say that define calculate population mean, and let us write the do and the end blocks. Now this function of calculate population mean receives a tuple, right? The first is our condition, the second one is our list of numbers. Now this condition can either be true or it can be false. So suppose we have a true condition, then we can have a pattern match right over here. But in case if it is false, then we can create yet another clause. So let me just copy and paste this one. So here I can say that in case the argument is false and we don't have to do anything with numbers, so let me replace numbers with my underscore. In case the first argument is false, that means the validation has failed. So here we can again send the same tuple error. So let me copy this one and let me paste it right over here. Now let us see how we can calculate the population mean in case the first argument is true. Now here the formula is very simple. First we have to take the numbers. Next we have to calculate the sum, and we can calculate the sum by using an inbuilt function. So we can say enum.sum. The next one is we simply have to divide the sum with the count. So for this, let us define one more function and let us call that function as mean. So this function is going to receive two arguments. The first argument would be for the sigma, which comes from this one. The second argument would be for the count, and we can pass the second argument right over here. So we can say enum.count, and let us pass the list of numbers. Now let us create this function right over here. So we can say define mean. The first argument is for the sigma, the second argument is for the count, and for this one the implementation is very easy. We simply have to divide the sigma with the count, and that's it. We have implemented population mean. But we can do a lot of improvements. So as you can see, we have some repetition. We have this tuple of error here as well as on the top as well. Let me also put some separator lines for our convenience. So this is going to be separate thing, and calculation for the population mean is going to be a separate section, and one for this one as well. So now let us go to the top and let us see how we can improve our code. So now the first thing is we have this error tuple twice. So let's create a separate module for errors. So let me open up my sidebar, and inside the directory of lib, let me create a new module called as errors, and let us define the module as stats.errors. Let us define a function over here. So we can say define invalid data types, and we simply want to return back the tuple. So let me go back to the file of mean and let me just copy this line. Let us go back to our errors file and let me paste it right over here. Now let us go back to this file. Let me collapse my sidebar, and now what we can do is we can create an alias on the top. So we can say that let us create an alias for our stats.errors, and we can replace this line with errors.invalid data type, and we can do the same thing right over here. So let me take out this line and we can say that errors.invalid data type. Now I want to do one more thing. I want to take out this function of validate into yet another module. And this is because I simply know that we would require this validation function for our future implementation as well. So inside lib, let us create one more file for validators. again let us define the module, and the module name has to be stats.validators. Let us go back to this file. I simply want to cut everything out, so let me take it out. Let us go to our file of validators and let me paste it right over here. Now for this one, we can do one slight validation since we have taken this file inside another module. So here we can do one small validation as well. So let's define a guard over here. So when is list for our numbers, and in case if this validation fails, then let us create one more clause right over here. So here we can simply ignore the argument and we can simply return back an error. So let me again create an alias for the error right over here. So let's create an alias for our stats.errors and let us return an error right over here. So here we can say that errors.invalid data type. Now the specification for this one is going to change. So this function of invalid data type, this returns a tuple. Let us define a specification for this one as well. So let us go to errors, and here we can say that the specification for our function of invalid data type. So this function does not accept anything, and this simply return backs an atom, and the next argument is of the type of string. So let me copy all of these things. Let us go back to our file of validators. So now what's happening is, in case if this number is a list of numbers, we send back a tuple, but in case the validation fails, then we simply send back an error, and the format for the error is we have an atom and we also have a message, right? The next thing is, since we have taken this function in a different module, let us go back to our module of mean and let us create an alias on the top. So here we can say that we want to alias yet another module. So we can say that we want to alias stats.validators. Now what we are doing is we are importing errors and validators from the same module of stats. So we can create an alias on the same line. Let me show you how. So we just have to wrap this inside our curly brackets, and we can say that we also want to create an alias for validators as well. Now right over here on line number 10, this function is inside our module of validators. So validators.validate numbers list. Let me take out these lines. Let me open up my terminal and we can go inside our IEX. Let us create an alias for stats.centralTendency.mean. Let me clear up everything and let us call our population mean. So we can say population mean and let us pass 10, 20 and 30. And as expected, we get back the answer as 20. Now let us pass an empty list and see what's happening. So in this case, we are getting back an error saying that error invalid data type. Now watch what happens if we pass some other argument. For example, if we pass A, B and C. So in this case, we get an error saying that no function clause matching. And this is because we have not defined a catch-all clause for this function of population mean. So let us define one clause right over here. So here we can say that define population mean. And in this case, we simply want to ignore the argument and we simply want to return back our errors dot invalid data type. Let me open up the terminal and let us recompile our module of mean. Let me clear up everything and let us try the same statement one more time. So this time we get a nice error saying that error invalid data type. So this is how we can create population mean. But we are not yet done. We also need to implement the sample mean. But luckily the formula for sample mean and population mean is the same. So let us very quickly implement our sample mean as well. Let me take out all of the comments. I don't need the comments. Let me paste the separator line on top. Now here let me again copy this separator line and let us create one more function for sample mean right over here. So here we can say that we want to define a function for our sample mean. Now this function accepts a list of numbers and we simply have to call our population mean and pass our list of numbers. So that's it. Now we have the function for sample mean and population mean as well. Let us also define the specifications for this function. So here we can say that the specifications for our population mean. Now this function receives a list of numbers and this function is going to return back a number or it is going to return back an error. Now the type of our error is like this. The first element is the atom and the second element is of the type of string. Let me copy this specification for our sample mean as well. Let me paste it right over here and let me change the name from population to sample. Next, we can do a couple of more improvements for our code. Now, if you see this function of calculate population mean and this function of mean, so these functions are just our private functions. So let us declare them as private. So this becomes our def of p, and this also becomes our private function. The same thing happens for our mean as well. This also becomes our private function. Now let me open up the terminal. Let us try and recompile this one more time. Let me clear up everything and let us try to invoke the same function one more time. Let us pass the list of 10, 20 and 30. So this is for the population mean, and let us try the same thing for our sample mean as well. So let me replace this with sample mean and we get the same answer back. Now what's happening is every time we have to create an alias, but instead what we can do is we can separate our public API from our private API. So if I open up my sidebar, we have a module for stats.ex, and as you can see that this file is not doing anything. So what we want to do is we want to make this stats file as our public API. So what I mean to say is the end users can just reference this single file to use all of the functionality. So let me show you how we can do this. Let me take out all of these things. These are not required. Let me collapse the sidebar and let us define a function for our population mean right over here. Now this function receives the list of our numbers, and from here we can simply call our function of population mean. So we can say that we want to create an alias for our stats.centralTendency.mean, and for this function we can simply delegate it to mean.population mean, and let us pass the argument of numbers. So now we have simplified our API quite a lot. Now let me open up the terminal. Let us recompile the module of stats. Let me clear up everything. Now what we can do is we can simply call stats.population mean and let us pass the argument of 10, 20 and 30 and we get back the right answer. Now let us go back to our code and we can do one slight improvement for this one. Now instead of just calling this function, we can use something which is called as def delegate. So first let me show you and then I can explain it to you. So here we can use the new keyword called as def delegate. The first argument is the name of our function. So the name of our function is population mean. So let me paste it right over here. Now this function also accepts one argument and the argument is for the list of our numbers. And now what we want to do is we simply want to delegate this function to our module of mean, and that's it. Line number 4 and line number 5 does the exact same thing. So let me comment out this line. This is not required. Let me open up my terminal. Let us recompile the module of stats. Let me clear up everything and let me call the same function one more time. And as expected, this is working just fine. Let us create one more def delegate for the sample mean. So here we simply have to change the name from population mean to sample mean. So whenever we call stats.sampleMean, this function will be delegated to mean.sampleMean. Let me open up my terminal. Let us recompile the same module. Let me clear up everything, and here I can say that stats dot, this time I want to calculate the sample mean, and let me pass the argument of 3, 4, 5, 6 and 7, and this time we get the answer as 5. Well, that's it for this video and I will catch you in the next one.